Today we're going to be solving exponential and logarithmic equations. The secret to solving an exponential or logarithmic equation is often in isolating either the exponential or logarithmic piece and then switching from either exponential form to logarithmic form or logarithmic form to exponential form. So let's try some of these. I have 7 raised to the x plus 2 power equals 2,401. And there is nothing I can do with that. So I'm going to change to log form, which would be log, the base is 7, of 2,401 equals the exponent, which is x plus 2. Notice that that has created a problem that I can do. Log base 7 of 2,401, I may or may not know. If I don't know it, then I can use change of base on my calculator. So I can do log of 2,401 divided by log of 7. And I get 4. So 4 is equal to x plus 2. Wow, isn't that easy? So x is equal to 2. Let's try another. 3 times 4 raised to the 2x minus 5 power equals 600. In this case, there is something I can do first. In fact, I have to isolate my exponential piece by dividing both sides by 3. So I get 4 to the 2x minus 5 power equals 200. Now there's nothing more I can do. My exponential piece is isolated, so I'm going to go to log form. Log, the base is 4 of 200 equals 2x minus 5. So log base 4 of 200 is not a pretty number, so I am going to have to use my calculator and change of base. Log of 200 divided by log of 4. Okay, that answer is the left side of my equation. So now I need to, while it's still in my calculator, add 5 to it, and then divide by 2. So my answer is approximately 4.411. Okay, let's try it again with base e. So I can subtract 3 from both sides. So 10 e to the x equals 722. I can divide both sides by 10. E to the x equals 72.2. And now I'm trapped. So if I go to log form, it would be log base e of 72.2 equals x. Hopefully we recognize log base e as natural log of 72.2 equals x. I do not know the natural log of 72.2. Natural log of 72.2 is approximately 4.279. This one is very interesting because if you look at it, it's a trinomial, which should make us think of factoring into 2 binomials, because there's no way to isolate my exponential piece because there are actually 2 exponential pieces. There's e to the 2x and there's e to the x, and those are not like terms. So let's try to factor this into 2 binomials. So e to the 2x would be e to the x times e to the x, because if you multiply e to the x times e to the x, you'd have the same base, and therefore you would be adding your exponent, and the exponent would be e to the 2x. The 6 probably is negative 2 times negative 3, because that would give me the negative 5 e to the x in the middle. So then I get e to the x minus 2 equals 0, and e to the x minus 3 equals 0. So e to the x equals 2, or e to the x equals 3. So log base e, so natural log of 2 equals x. Log base e of 3, so natural log of 3 equals x. So my x's, natural log of 2, or natural log of 3. So 0.693 or 1.099. So I have two possible answers. Let's look at some logarithmic equations. In this case, I cannot add 6 to both sides because it is part of the argument of the log. So the best I can do is switch to exponential form. Base is 7, exponent is 2, equals x minus 6. I know 7 squared is 49. So x is 55. In this case, there are things I can do first. I can subtract the 4 from both sides. So 5 log base 2 of x is 40. I can divide both sides by 5. Log base 2 of x is 8. And I can either know this, or I can go to exponential form. 2 to the 8th equals x, which I may or may not know. 2 to the 8th, that's 256. So x equals 256. Let's try it again. Now I have two logs, so I cannot isolate them as one unless I can condense them into one log. So I can, it's a subtraction, and they both have base 3. So log base 3 of x over x plus 2 equals negative 1. Now, since I have a single log and it is isolated, I can change to exponential form. 3 to the negative first equals x over x plus 2. 3 to the negative first is 1/3 equals x over x plus 2. I'm going to do a cross product. So 3x equals x plus 2. 2x equals 2. X equals 1. My answer is 1. Now, when the problems are about logs, it is good if you've done some condensing to check to make sure that your answer is in the domain of each of the logs in your problem. So 1 is definitely in the domain of base 3 log, and 1 plus 2, 3 is definitely in the domain of a base 3 log. Here we have natural log of 2x plus 5 equals 4. There's nothing I can do, so I'm going to go to exponential form. The base for natural log is e to the 4th equals 2x plus 5. So I'm going to have to find e to the 4th. That's a number. Subtract 5 from it, then divide 2, and that will be my x. So, oops, I forgot what the problem was. E to the 4th. Okay. E to the 4th. Where's my e? Raised to the 4th. Okay. From that number, I want to subtract 5. And then I want to divide by 2. So my x is approximately 24.799. Alrighty then. That's my next lesson. So we are done for this one.